Nice. Hello, everybody. Hello, hello. Third panel for me for the day, and it's my first time to be in the AI Summit stage, but we're actually talking about the Industrial Revolution. And I feel already very privileged because I already had a bit of a discussion with Craig yesterday for my interview for the economy around what he's building and what he's doing, and I'm really excited to have this discussion and share it with everybody here. But just to prelude this session, so we are going to talk and discover how Geminus AI is leveraging artificial intelligence to optimize manufacturing processes and revolutionize energy systems. Energy is very important. Changing it and actually being able to be sustainable around it is super critical right now. And at the same time, like talking about a next industrial revolution, we all probably know from history books what the industrial revolution did to our society and civilization. So Greg Fallon, he is the CEO of Geminus AI, and he's passionate about solving the world's most complex problems faster. And he's a lifelong nerd and seasoned executive, has led some of the most innovative product initiatives in the industrial software world over the last 25 plus years. So, Greg, to set the stage right, tell us a little bit about yourself and your background. I'd love to hear about the anecdote you shared with me yesterday around how this whole thing started with you and your lifelong journey.
Yeah. Well, thank you, and thanks so much for joining us today. Um, yeah, so my journey began back in the 90s. So I was getting my PhD in mechanical engineering. I got really excited about the rise of computing at the time. Computing was becoming less expensive, and there was a trend in the engineering space. I was studying mechanical engineering to take algorithms that were being built in academia and bring them to industrial companies so that engineers can simulate the world around them. Before the 90s, engineers would have to come up with an idea, go to a laboratory, build it and test it, and keep doing that. The idea of simulation was to allow engineers to explore computationally what was happening. And so I got really excited about that. I quit my PhD program, joined a startup. That startup is now a multi-billion-dollar company. And so as my career continued, this whole idea of having intelligence of the world around us in a virtual environment has been very captivating. With the rise of machine learning in the kind of 20-ish, 2004, 2005, I got more excited about how the two can come together. And that's really where my company, Geminus, started.
Awesome. Um, so you've already done a lot of things in the space, and now you took this new problem and you're trying to solve it. Can you tell us a little bit about Geminus AI and what exactly are you doing there?
Yeah, so one of the things about the industrial environment that's a little different from the consumer environment, where we're using tools like ChatGPT, is that in the industrial environment, precision counts. High precision counts, right? When you're dealing with an oil refinery that has tens of thousands, if not 100,000 barrels of oil flowing through it a day, you have a lot of heat, a lot of energy, and decisions on how to control that refinery have to be precise. Otherwise, you can harm the refinery and you can harm human beings. So there's a big difference in the requirements for the artificial intelligence. Because of that, an entirely new field of AI training came about in the engineering space. Starting around 2002, 2004, people started to look at how to make very high precision predictive models deploying neural nets. And that spawned into an entire academic field. My co-founder is one of the pioneers in that field. He's now our chief scientist and continues at the University of Michigan as one of the leaders now in this idea of scientific AI. So what Gemini essentially does is take these advanced algorithms tailored for industrial applications. We bring them to life in industrial complexes through our software platform. We do things specifically in the energy sector where you're combining things like sustainability with productivity. So an example of an application we finished earlier this year that is now going to commercial deployment is using artificial intelligence to help energy companies figure out how to extract gas from the ground without flaring it to the atmosphere. It's a pretty important problem environmentally because methane is a greenhouse gas that is many, many times more potent than carbon dioxide. It also is important to the companies that generate natural gas not to take your sales product and flare it to the atmosphere. And so through the use of our techniques, we're able to create very reliable, high-precision models that help the engineers understand how to control their gas wells better and avoid flaring. And we do that really across the energy supply chain.
So, I mean, we all know, or I'm assuming the majority of people know, like, and use as a consumer, from a consumer standpoint, AI. So they're using, the AI agents now or chatbots to potentially help them work on through problems. So, from your perspective, I mean, you're doing something that is very beneficial to the environment, saves energy, optimizes operations. But how does an engineer use this tool differently? So do you use it as well as in a B2C sense where they are potentially trying to solve together problems, or do you use it differently where you collect data points and essentially build models, as you said, where it helps the engineer to map out solutions?
Yeah, if there's any engineers in the audience, they're probably going to get mad at me. But the way that, a very simplistic way to think about this is ChatGPT for engineers, right? So in the example I just gave of the natural gas network, the tool is giving recommendations to the engineers on what actions to take next. Turn up this pump, turn down that valve, and it's monitoring the conditions of the gas wells, the conditions of the atmosphere, which has an impact on the gas in the pipeline, and the conditions downstream at processing facilities. So it's looking dynamically across this entire network, and it just helps the engineers manage the complexity that they have to deal with on a day-by-day basis. Prior to what we did, the engineers really had to use a combination of experience, which can be difficult when you're dealing with extremely complex networks that have hundreds of thousands of possibilities and combinations for connections. And they also would have the benefit of using some of the simulation tools that I helped create earlier in my career. The only challenge with those simulation tools is that they're really not usable in real time. You're talking about having to wait a day to get an answer when you have to make the answer in a few minutes.
So that's still to be optimized. You've already provided an example of a problem that you're trying to solve right now. Can you give us some other areas that they're more promising at the moment for this kind of applications? And what types of energy systems are being impacted?
Yeah, so we're looking across the energy spectrum. We're starting with traditional oil and gas companies, helping them be more productive, yet more efficient and more sustainable. We're then looking at renewable sources. We have work going on in carbon capture, where we're helping engineers design carbon capture systems so they can perform optimally. You can extend that to things like the electric grid. One of the big problems we're starting to look at is the expansion of the electrical grid. So one of the things that not everybody realizes is that as we electrify our world, we have EVs and new electrical devices that are powering factories and data centers. We have to get more electricity, and that requires a new electrical grid, the wires that transmit the electricity. And it took 130 years for the world to create all the wires that generate the electricity we have today. We have to double that in the next 20 years, and that's a massive engineering undertaking. So that's an example of something we're looking at. Beyond that, we're looking at the chemicals industry, the materials industry. We're even doing some work in space.
What I find is interesting is that, I mean, because we also use this as an example that is about the Industrial Revolution, right? And we know that the Industrial Revolution, as it was, is what led us now to the point where need to work on projects and problems that want to scale down the energy power that we're using. So how is this next Industrial Revolution looking like from your perspective?
Yeah, so it's interesting. People use the phrase industrial revolution in very different ways. I think people talk about the new industrial revolution as an AI revolution when we're talking about artificial intelligence in general. I'm thinking about it from a mechanical engineer's perspective, which is really the blending of the old industrial technology with the new technology. And the implications there are that we can better use the old technology, things like mechanical cars and power plants, much more efficiently by deploying this new technology. And so where I see this going over time is more and more automation of the thinking that is done to operate the old technology and also in planning and creating new advancements in it.
Interesting. Yes, that's true. Like, I mean, you can see it from multiple sides, and for sure, like saying it is optimizing actually what already is there. Is there's a new revolution on its own. You know, I come from like the media where we're focusing a lot on data and AI. So I'm really passionate about anything that has to do with data. So I'm wondering, what kind of data is required to train and deploy AI models for manufacturing and energy optimization? And where do you get that data from?
Yeah, that's a really good question. So first of all, let's just talk about data in the industrial world, right? So I think ChatGPT 1.0 was trained on 45 terabytes of data. If you look at a typical oil field, there's no typical oil field, but if you kind of take an average, an oil field can generate a terabyte of data a day. And so you have these large industrial companies sitting on just massive amounts of data. That type of data is often measurement data, you know, temperatures, pressures, how things are moving within machines. And so, you know, helping industrial companies unlock that data is very important. Now, one of the things that we do to that data is we also blend in what I would call synthetic data. So if you remember, my background is in simulating things around us with high precision simulations. Almost every industrial company around the world has these types of simulators, and so blending that in with the traditional data, and the traditional data could be sensor data, it could be image data, and blending it all together to make these high precision models is what we do.
And where would you normally get this data?
So it comes from a range of places. Every industrial company has a different strategy for data. In many cases, the industrial plant is old, and there are only a few sensors. In some cases, there are loads of sensors that are pulling off tops of data, and those are stored in databases or data historians. The synthetic data is generated by engineers who are operating these particular plants, and so we bring those two together.
And would you say like having these data sources is one of the biggest challenges, or what would you say are the biggest challenges for manufacturers and energy companies when it comes to implement AI-driven solutions?
Yeah, well, there's loads of challenges in the industrial sector. So one of them is getting the data, storing the data. I think that's a challenge that is fraught but well established. I think trusting the data is another big challenge, right? So when you have a bunch of sensors on an offshore oil rig, those sensors are exposed to saltwater, very harsh environments, so they tend to drift or not be reliable. So there's this whole issue of validating the data, which is one of the reasons why we use multiple sources of data so that we can cross-calibrate against each other. Another major issue in the industrial world is cybersecurity, right? So in this part of the world, there are data sovereignty laws, so you can't necessarily have data flowing from a gas field here into an Amazon data center located in Seattle. So you have to think about ways to kind of have your compute local. It gets even more complicated because you can do your AI training in a centralized data center, but a gas field or an oil field might have edge compute that's associated with it. That edge compute might be 15 or 30 years old. So you then have to figure out how to run your model securely on an old piece of hardware. So you have these kind of challenges across the sector that are then exacerbated by the fact that industrial plants change on a day-by-day basis. And so if you have an oil refinery that's working today, tomorrow it may go into repair. Or you may be getting a new feedstock from another part of the world. So you have this dynamicism that happens in the industrial world, and in order to make these accurate predictions, you need to be able to have models that can be quickly retrained or recalibrated, which is another massive problem that takes place.
And from your perspective with Geminus AI, what kind of approaches do you have to help businesses implement those AI solutions in their companies?
Yeah, so we have a software platform that automates the creation, deployment, and management of these models. Typically, either Geminus or one of our partners will help our end customer deploy the platform locally. In some cases, we'll run it for them. The output of the models actually connects into either internal applications that are bespoke for that organization, or sometimes there are applications that need to be created. So we'll work hand in hand with the customer. Sometimes it's their internal teams that are doing that. So there's a variety of implementations, not dissimilar to the way that ERP systems are deployed.
And then last, but certainly not a least question. So looking ahead at what's going on, the emerging trends, let's say, in AI technology, what are you most excited about? And maybe to put it on the words of like how you would perceive it, what complex problem are you most excited to solve?
That's a really good question. I think one of the things that gets me most excited right now is just like we had the LLM revolution over the past several years, deploying generative AI, that same type of revolution is happening in scientific AI. So there's a trend around these massive foundation models. We are working actively on new technologies that will allow you to have larger and larger models. And so we can work on a single refinery, we can work on a network of refineries, we can work on a network of refineries that are connected to the oil pipelines that deliver the oil, and we could connect that all the way back to the reservoirs. And so this concept of an enterprise foundation model or an energy foundation model is very, very exciting. We have some pilots ongoing looking at that, having at a country level and also at an enterprise level. So I think that this power of artificial intelligence and looking at larger and larger systems is incredibly exciting. And I think that as you start to deal with complexity at the enterprise or the country level, you start to talk about benefits that just compound, right? So if you're saving 5% on a single refinery, you're looking across your network, you're looking at saving not only that refinery, but the pipeline that's delivering the oil all the way back to the reservoirs and optimizing across your entire organization.
That's amazing. And anything that you're working specifically also on not only a technical problem, but let's say a societal problem, the decarbonization that you mentioned to me?
Oh yeah, so well, there's that, which is critically important. So I am super excited about the way that we can help companies navigate sustainability. We've shown in benchmark after benchmark that we're able to help the companies we work with not only make more money, but reduce their carbon footprint. And to me, that's really exciting because we don't have to worry about some sort of incentives for the companies. They're financially incentivized to be more sustainable. And so we're continuing to pull on that thread, and I think it's a very powerful one.
Awesome. To solving bigger problems and decarbonization. Thank you very much, everybody. Thank you.
Thank you so much. Thank you.